From efficient sea haulage to efficient rail solutions, the German Aerospace Center has been working on the high-speed train of the future, with the aim of reducing energy consumption by as much as half. Joining us now in the studio is Dr Joachim Winter from the Center's Institute of Vehicle Concepts. You've brought along a model of the next generation train, the NGT. It's obvious, it's aerodynamic. What puts this aside from the ICE train, though, Germany's ICE?
The difference is that we try to halve the energy consumption per seat compared to the ICE3, and therefore we have to do some things on the materials and the propulsion concept and also on the aerodynamics. And this shape of the nose of the train is given by the to handle the pressure and the tunnel entry and to avoid microbursts at the tunnel out.
So it's a lot pointier. You've also got two stories to this one? So it's Doppelstock?
This is a double-deck train to have more passengers in the train than compared to the IC3.
What other factors are involved? Engines, new materials?
It's new materials, and on the first hand, we are going from aluminium and steel to composites, multi-material design. And that means that we have a light end car, and that means we have problems with the crosswind, and that we have to solve aerodynamically.
Have you had any problems with the cost?
We have also problems with the cost, maybe, but it depends on the complete view on the life cycle costs of a train. So the investment and the operational costs.
Okay, this is a speedy passenger train. What about freight trains?
For freight trains, the rules are the same. So you have to cover all the loads on a freight train and to make sure that it is a seamless surface on that train as well. So you have also to cover the gaps between the wagons and so on and so on.
And where do you test all of this? Do you have a test track or test tunnel?
We have different wind tunnels. We have the world's only wind tunnel for tunnel passing and crosswind. And we have laboratories for passenger comfort, air conditioning. We have stress test machines for the materials and so on and so on.
Now, we're talking about a very fast train. Are we also talking about safe travel here?
Yeah, safe travel is at the first. So that means we have to take care of the crosswind to make the train minimum as safe as the trains are now.
A quick question for you. When are we going to actually get to ride in one of these trains?
We are not building the train, but we are passing over the technologies we are developing also already now. So during the run of the project, we are passing over the results to the industry.
Dr. Joachim Winter, thank you very much for coming in. A pleasure to talk to you.
Thank you very much.